Hey everyone, hope you're all doing great. Today we're going to explore how to make decisions in Python using conditions. Conditions allow us to control what happens in our code based on whether a certain statement is true or false. This is important because in real-world programs, we don't always want everything to run at once. Instead, we want to decide which actions to take depending on the situation. Let's start with a simple example. Imagine you're at a fruit shop and want to check whether apples are available. If apples are in stock, we print a message saying, apples are available. If the condition is true, this message gets displayed. If it's false, nothing happens, and the program moves forward. Now, what happens if we change the fruit to banana? Since the condition is no longer true for apples, the program simply skips over the message and does nothing. This is the basic idea of an if statement. It only runs the code inside it when the condition is met. But what if we want to handle cases where apples are not available? Instead of allowing the program to do nothing, we can define an alternative action using an else statement. This way, if apples are in stock, we still print, apples are available. But if they aren't, we print, sorry, apples are not available. This ensures that the program always responds with a meaningful message rather than just doing nothing. Now let's take this a step further. What if the shop sells multiple types of fruit, and we want to print a message depending on which fruit the customer asks for? This is where we can use else if, which is written as elif in Python. First, we check if the fruit is an apple. If not, we check whether the fruit is a banana. If neither condition is met, we display a generic message saying, we don't have that fruit right now. For example, if a customer asks for bananas, the program prints, bananas are available, they are rich in potassium. If they ask for mangoes, the message will be, mangoes are sweet and delicious. However, if they request a fruit like grapes, which we didn't specifically check for, the program prints, we don't have that fruit right now. This approach helps us handle multiple situations without writing too many separate if statements. One important thing to remember when using conditions in Python is indentation. Unlike other programming languages that use curly brackets or keywords to define code blocks, Python relies on indentation to group related lines of code. When writing an if statement, every line inside the block must be indented consistently, usually with 4 spaces or a single tab. If indentation is incorrect or inconsistent, Python will throw an indentation error and the program won't run. Proper indentation ensures that the program clearly understands which lines belong inside the condition. Comparison and logical operators. When writing conditions, we often compare values to check if they meet specific criteria. Python provides several comparison operators to make these checks. The equal to operator checks whether two values are the same, while the not equal to operator checks if they are different. We also have less than, greater than, less than, or equal to, and greater than or equal to operators, which compare numeric values. For example, if we want to check whether a customer is buying at least 5 apples, we use the greater than or equal to operator. If the number of apples is 5 or more, the shop confirms the purchase. Otherwise, it might inform the customer about the minimum order requirement. Sometimes we need to check multiple conditions at once. For this, Python provides 3 logical operators, and, or, and not. If a shop allows a purchase only if a customer is old enough and has enough money, both conditions must be true. If they are at least 16 years old and have 50 units of money, they can buy the fruit. However, if they only have 30 units, even though they meet the age requirement, they still can't make the purchase. The AND operator ensures that both conditions must be true. On the other hand, if a shop allows customers to buy fruit if they either have enough money or are accompanied by an adult, we use the OR operator. As long as one of these conditions is true, the purchase can happen. This makes the program more flexible. The NOT operator works differently. It reverses a condition. Suppose we want to display "you need to bring more money" when a customer does not have enough cash. Instead of checking if money is less than the required amount, we can simply use NOT to make the condition easier to read. Nested if statements. A nested if statement is when one if statement is placed inside another. This allows us to check multiple conditions in a structured way, ensuring that a second condition is only evaluated if the first one is met. For example, if a shop has apples and we also want to check whether they are fresh, we can first verify if apples are in stock. If they are, we then check if they are fresh before confirming the purchase. This kind of nested if structure helps in situations where multiple conditions need to be satisfied sequentially. However, too many nested if statements can make code hard to read. Python provides a shorthand if statement, allowing us to write simple conditions in a more compact way. Instead of using multiple lines, we can place the condition and statement on a single line. For example, to check if apples are in stock, we can write it this way. This is useful for quick checks, but should be avoided in complex conditions for better readability. The ternary operator is another way to simplify conditions in a single line. The format is value, if, condition, else, alternative value. For instance, if we want to store a message about apple availability, we can write this way. The pass statement. Sometimes we need to write an if statement but haven't decided what action to take yet. In such cases, Python provides the pass statement as a placeholder. It prevents errors when an empty block is required but doesn't execute any code. If we check whether apples are in stock but haven't implemented the action yet, we can write if apples in stock, pass. The pass statement is often used when writing incomplete functions, loops, or class structures. In Python, the is operator is used to check whether two variables refer to the same object in memory, rather than just comparing their values. This is different from the equal to operator, which checks whether two values are identical. For example, if we create two lists, both containing the fruits apple, banana, and mango, they will have the same values. If we compare them using the equal to operator, Python will confirm that they are the same because their contents match. However, if we use the is operator, Python will return false, because even though they contain the same values, they are stored as two separate objects in memory. We can verify this by printing the memory addresses of both lists. They will be different unless we explicitly assign one list to another. If we do that, both variables now reference the same object, and using the is operator will return true. This concept is especially important when working with mutable objects like lists and dictionaries. Finally, Python automatically treats certain values as true or false in conditions. Some values always evaluate as false, such as false itself, none, the number 0, empty strings, empty lists, empty tuples, and empty dictionaries. Everything else is considered true. This means that instead of checking if the length of a list is greater than 0, we can simply write if list name, and Python will handle it automatically. Conclusion. To wrap things up, we use conditions to control the flow of our programs by deciding which actions should be taken based on different situations. The if statement allows us to check a condition, the else statement provides an alternative action, and elif helps us check multiple possibilities. Operators like equal to, not equal to, less than, greater than, and logical operators like and, or, and not allow us to write more powerful conditions. Python's built-in handling of true and false values makes it easy to work with different types of data. That's all for this session. In the next session, we'll talk about loops and iteration, which will take our programming skills even further. If you have any questions, feel free to drop them in the comments. If you found this useful, don't forget to like, share, and subscribe for more content. Thanks for watching.